Lesson 52, determining the equation of a line given 2 points, or the coordinates of 2 points. Here we have a graph, piece of graph paper, and we have 2 points that are located. This point has coordinates of -3, 1, 2, 3, up 2, and this point has coordinates of +2, 1, 2, up 1. What would be the equation of the line given these 2 points? Well, we would need to use our formula, y equal mx plus b, our slope-intercept form that we talked about several lessons ago. So we have a formula for m. M is equal to y2 minus y1 over x2 minus x1. These are subscripts. And we need to pick one of the points for point 1 and the other for point 2. It doesn't really matter. Let's pick this point for point 1 since it's closest to me here, and this point for point 2. Now we'll figure our slope m is equal to y. The y value at point 2 is 1 minus the y value at point 1 is 2 divided by the x value at point 2 is 2 minus, and the x value at point 1 is -3. So -3. 1 minus 2 is -1, and 2 minus a minus is a +3. So our slope then, m, is equal to -1 over 5. There's our slope. Okay, our slope then is -1 over 5. So we put that back into our formula for y equal mx plus b. Let's see, maybe we could just write over our graph here. Y is equal to -1/5 x plus b. And we pick one of the points and put in values for x and y. Let's pick this one over here since they're both positive. Y value is 1 is equal to -1/5 times the x value at that point, 2 plus b. So we got 1 is equal to minus times the positive is a minus 2/5 plus b. We add 2/5 to both sides. And we get that b is equal to 1 and 2/5, or we could write that as 7 over 5. So the equation of our line then would be y is equal to -1/5 x plus 7 over 5. Now let's look at the graph. If I could just sketch in the graph of that line. Is this line going, if that had been straight, is it going down to the right? Yes. So it should have a negative slope, and it should pass the y-axis, pass through the y-axis at about, at 7 over 5. Well, that's a little over, a little less than 1.5. So 1.5 would be here, sure enough. It's about a little less than 1.5. Okay, now let's graph a line that has a slope of 4 and passes through point 3, 4. Okay, so we need to locate the point first. So let's locate the point. 1, 2, 3, up 4, 1, 2, 3, 4. They would be right there. And it has a slope of 4. Now the slope of 4 means it goes up to the right. Well, if we start here and go up, we're going to run off the graph. So we can start here and come down, though, and still have a rise over run. See, m is also rise over run is equal to 4 in this case, and 4 we could write as 4 over 1. Okay, so we're going to rise 4 from here. So from here we go down 4, 1, 2, 3, 4, and run 1, so right here. And here would be our line. Oops, we come a little closer that way. Something like that. And notice it goes up to the right. Well, let's do 4. We don't know where it crosses the y-axis. It crosses the y-axis way down here or something. That's okay. All right, let's move on. Okay, now we have another form of an equation. It's called the point-slope form. It's very similar to the slope formula for slope, which is what? M is equal to y2 minus y1 over x2 minus x1. We just simply multiply both sides of the equation by x2 minus x1, Whoops. And if we multiply this side by x2 minus x1, they would cancel, so that would be y2 minus y1. And since we only know one point, we just use the 0.1 values here, and we just remove the 2's here. So this becomes our point slope form of the equation. Notice I have it written backwards, but it's the same. If it's equal to this, if this is equal to this, then this is equal to this. Okay, so where the m is the slope, and x sub 1 and x and y sub 1 are the coordinates of the point that the line passes through. What is the equation of the line that passes the slope of 3 and passes through the point 1, 2? Okay, we can use this form of the equation. Okay, we know the slope is 3 times x minus x1, well, that's minus 1, and that's equal to y minus y1, and this point is what? Is 2, so we can multiply this out, and we get y minus 2 is equal to 3x. Now, minus and minus is a plus 1. 3 times 1 is plus 3, and then we could add 2 to both sides if we wanted to do that. And we would get y is equal to 3x plus 5. Now let's graph that and see what we get. Okay, let's graph that. Okay, it passes through minus 1. I think this would be about minus 1 up 2. 1, 2, right here. And has a slope of 3. That means it goes up to the right, down to the left, 3. So let's do this. Let's go 3 down, 1, 2, 3 here, and 1 this way. That would be 3 over 1. So we pass through that point, so that would be the line. Have a y-intercept up here somewhere. What is that? Y-intercept would be 5. So this is 1, 2, 3, 4. Sure enough, about 5. Right there. Be about 5. Write the equation of the line that passes through the points 1, minus 3, and 4, 5. Okay, let's locate the points first. 1 minus 3 would be here. 4, 5, out 4, up 5. Well, where's 5? Well, 5, here's 4. 5 is going to be up here somewhere. Okay, so here would be our line. Does it have a positive slope or a negative slope? It has a positive slope. It goes up to the right, and it crosses the y-axis. And we can imagine down here somewhere, down in here, that's minus 4, minus 5, maybe even minus 6, somewhere down there. That just gives us an idea about what the equation should look like. Okay, let's write it in point slope form. Well, first we have to determine the slope. M is equal to what? Y2 minus y1 over x2 minus x1 is equal to. All right, let's pick a point. Let it be one of. Let's let this one be 0.1, and this one be 0.2. I always put Roman numerals over my points to keep my x's and y's straight. Okay, so y2 would be 5 minus y1 minus a minus 3 divided by x2, 4 minus x1, 1. 5 minus a minus is plus 3, so this would be 8 over 4 minus 1 is 3. So our slope is 8 over 3, or 2 2/3. We probably best leave it as 8 over 3. Okay, so in point slope form, our equation then would be, what is our equation? Our equation is y minus y1 is equal to m times x minus x1. Let's go back, let's look at that, make sure. Sure enough, here it is, right here. Okay, so we got the right formula. Okay, so y minus y1, which one do you want to be y1? Well, since we've labeled this point as 0.1, let's use minus 3 here. So we got a minus 3 is equal to the slope we already figured as 8 over 3 times x minus x1, and x1 was 1. Okay, so we multiply, add like terms here. So minus and minus is plus, so we get y plus 3 is equal to 8 over 3 x minus 8 over 3. We could subtract 3 from both sides. Subtract 3 from both sides. Well, we can't subtract any, add these like this, so we'd have to convert our 3 to 9/3, so it's minus 9 over 3. So we got minus 8 over 3 minus 9 over 3, which is minus 17 over 3. Is our value there, and we will get y is equal to 8 over 3 x minus 17 over 3. And that is actually in slope-intercept form. Now let's do it in slope-intercept form. Use that formula. What is that formula? Y equal mx plus b, and see if we get the same thing. Okay, so we know our slope already is 8 over 3. We pick one of the points. Let's pick this one. We could pick this one. It really doesn't matter. That's equal to, the y value is 5. 8 over 3 times the x value at that point is 4 plus b. So we have, move it up a little, 5 is equal to, let's multiply this, 32 over 3. That's plus b. Let's move the 32 over 3 over to the other side by subtracting 32 over 3 from both sides. Can't really subtract this. We'd have to convert the 5 to thirds. I believe that's 15 thirds plus b here. So we would get, b is equal to 15 thirds minus 32 thirds, I believe is minus, what is that, 17 thirds. And sure enough, that's what we got there. So our equation in slope-intercept form would be the same as we have up here, y equal 8 thirds x minus 17 over 3. Okay, here's our homework for lesson 52, 1 through 19, 21, 27 through 30, and please email me the answers to problems 12 and 28.